Good morning, everyone. Thank you for coming this great opportunities, and just my friend, here, and also welcome to our university and giving us these great opportunities. So this is 3D printing, as far as I know. I mean, this is the one the recent development of analyzing materials or chemicals or molecules, whatever. So we are going to, stage is yours. We are going to present us. Actually, I bring some material here.
Yes.
Yes.
After
that, maybe we
After
can just
presentation, we can put your sample on the hands-on session.
That's what we suggested.
That's great. Yes.
Okay, I'll see.
You can.
Yes, sure. No, thank you. Good morning, everyone. My name is Mustafa Gladan. I'm a country manager of Troku Test group in Bosnia, and we have a pleasure to introduce you one of our vendors, a Japanese company called Hirox. They have in their offer 3D microscopes, and also they have scanning electron microscopes, tabletop scanning electron microscopes, which are one of the leading microscopes in this industry. Now we have a pleasure to introduce you our new model of the 3D video microscope, and as we were saying with Mr. Ali, or actually you can bring any samples that you have that you would like to see under this microscope after we finish the presentation. So during this presentation you can pay attention to what microscope can do, and maybe you're going to get some ideas what kind of samples you can bring or you would like to see under the microscope. Mr. Ali, Mr. Kossel, he already has some samples with him, but if you have something else that you would like to see, we will be open for the demonstration. Now, not in our, we're ready?
2 minutes.
2 minutes, okay.
So after the presentation, you are going to leave this by microphone.
Yes, we're going to leave this here, we're going to set it up in any room you want, and then we just send you a bill, no problem. We agreed on that already. So, you have 30 days to pay, no problem. Money back guarantee. Don't worry about it. You'll be satisfied. So basically, I'm going to introduce you our colleague Nordin, who is working directly for Hirox or Hirox, how do you say? Hirox. Anyway, whatever. He's working directly for Hirox, and he will lead this presentation and also the demonstration which will follow. Thank you.
Thank you. Good. I would like to start with a short video presentation. Do something? Yeah. So the short video presentation. So you can see the basic functions. After that, I will explain them with a PowerPoint presentation of the company and of the basic functions. It's the new generation microscope Hirox. And now I will present it to you with a quite short PowerPoint presentation. I will try to make it quick. And I would like to concentrate on your questions. So please, if you have any questions, if you have any applications you would like to test or to ask about, please don't hesitate.
I have one question.
Yes, please.
How much?
Depends. What is your application?
Priceless.
I like to say something. For the scientists, doesn't matter how much it costs. They have to say, do they need it or not? And then it's on
How much
financial management.
Yeah.
Thank you.
Yeah. Good. So a short company profile of Hirox, which was created in Tokyo, 1978. They started first with optical manufacturing, so only producing lenses and adapters for lenses, nothing else. This is the key components of Hirox. So the lenses are the most high-quality lenses in the world, and with the highest accuracy. Also good for measurements, for 3D measurements, and giving a great full HD, or even in this case almost 4K image. In 1985, they combined the quality of the lenses with high-quality video imaging, cameras and computers. So they actually basically invented and pioneered the video microscopes. So Hirox was the inventor of the video microscope, of the combination of lens, magnification lens, plus camera. During the years, they created a lot of other interesting methods for inspection. I will show you on the microscope and later in the presentation as well. For example, the 3D rotational head, which is now running on the microscope, you can see it. It gives a nice 3D overview of the object. Also a lot of lighting systems, stands, etc. We will talk about it later. This is a short evolution of the Hirox microscopy systems. The most interesting in your cases will be those two, the KH8700 on the left and the RH2000 on the right, which is this one. The newest model was announced 3 months ago. The basic difference is that the KH8700, the left one, is an all-in-one unit. All functions, all software, all in one computer. And the RH2000 is more flexible. You have additional softwares. You have you can use it with a normal Windows computer with USB 3 connection. And also the image quality is a little bit better. Good. The basic configuration of the RH2000. You will need the PC, which is USB 3. High-end PC would be good for good image quality, good video quality. Then you will have the compact main unit, which is camera processing, motherboard, and light source. And then you will have the stands and the stages. We have a lot of different ones. So if you're interested in some special stands and stages, some special made items, we can do almost everything. I can show you pictures later of some special made items. And then also the most important thing is the lens, the objectives and the adapters. You should have some lists over there, so you can also take a look, but I will also show you a rough overview. So new sensor technology. This is the new Bionet mount. We didn't have this before. It's a new technology which uses basically one mount to put it on the lens, and it combines the light, the camera, the communication to the lens. So automatic recognition of magnification, for example, and is compatible to any lens we currently have. So this is also the basic system configuration. This is a rough overview of our lenses and adapters. It's not all of them. There is much more, but this is the commonly used ones. You will have the 2016 lens, which is the lens I just mounted on the microscope. It has magnification from 20 to 160 times. You can expand this with several adapters from 6 to 320. And this lens is basically our rotary head lens. It has the highest quality rotary head. The next one is the 5040 lens, which has a magnification from 50 to 400. You can also expand with adapters from 20 to 800. And this has also a lot of different rotary heads with high magnification, low magnification, variable angles, and a lot of different possibilities. The 10C lens, the fourth one over there, is our highest magnification lens. You can go from 35, here it says 7,000, we now have 10,000. You just need to change objectives and you can fulfill the whole range of possible optical magnification. And our best high-end lens is the 2500 revolver lens, which has a magnification range from 35 to 2500 with only one objective. I think three objectives, but you can turn them so you have all in one. You don't need to change objectives, you don't need to change lenses. It's very easily to use and fast for image processing. This one, we also have a special made item which can magnify up to 5000. So we have a magnification range from 35 to 5000, which only Hirox produces for now on the market. There is nothing similar. Yeah, and also different macro lenses and BGAs and endoscopes for different uses. If you have questions on those, just please ask. So this is the rotary. I will just say a few words to that. Basically, it's a patented system by Hirox, so no one else uses it. A few other companies have something like a rotary head, but they don't really show it because we have a patent on this, and it's not the same quality, it's not the same image quality. In this case, with the 2016 lens, we have a 45 degrees angle, and you see, if you look with a normal microscope, you will just see the flat 2D surface. You don't know nothing about it. And if you use the rotary head, you will see all of it. So this is the revolver lens. A few pictures with the revolver lens. From, 35 magnification. The first picture, the second is 140 magnification. The two pictures below are, again, 140 and 700 magnification, but with the other lighting system. It's also a Hirox patent we have. It's called ring light and coaxial light. You know those terms probably. Ring light for use with low magnifications, coaxial light for use with high magnifications. In this case, coaxial lighting is much better to get the contrast better and to do measurements. Also for 3D measurements, the coaxial light with high magnification is much better. And yeah, the most important thing with this is that you can use both at the same time. So you can switch from ring light to coaxial light, but then you can also switch between. So you can give a little bit ring light, a little bit coaxial light. And this is a very unique feature, which gives you the possibility to adjust the lighting to images which are not easily, which affect very hard. So if you do this adjustment, you get quite better images. So like this, for example. So here, for example, you can also measure the roughness because you have a lot of details. This is also something. The first two images are made with coaxial lighting. The second, the lower images are made with ring light. This is the stands and the motorization. This stand I have here is the inclination stand with a motorized stage. The Z-axis is automatically moved with a joystick or with the computer software. The precision is 35 nanometers, so this is also the height precision you can measure. And the precision of the XY stage is 14 nanometers. Also both the most precise of the market. Yeah, this is one of the special stands I was talking about. This was made for the Rijksmuseum in Amsterdam. It's 2 meters times 2 meters and 1 meter. It's very large. They use it for scanning of paintings. In this case, they scanned the whole painting in, I think, 140 magnification. It's a very, very large data you need to process, but you need to do this for restoration. This is the flexible arm stand. You can just easily mount it on any table and just take the lens and move it wherever you need it when you have larger objects. This is the video glasses we use when you work under the microscope. You can surely watch the monitor and then watch back to look back to your sample, monitor sample. Like this, you can use both at the same time. You have glasses with a video in there, and if you look down, you can see the sample. If you look up, you see the picture of the microscope image. So now to the basic features. 3D multi-focus scanning. You capture different images in different heights. So that the z-axis is moving up and down, and like this, you're generating information about height of the sample you're using. So you will get a few images, depends on what precision you need, and now you will get a nice 3D model, which looks like this, or like this. And here you can do different measurements, image profiling, all measurements that are common. And also roughness testing, roughness measurements, and surface roughness. Yeah, 3D image profiling, you have 4 basic functions. The 3D display, so just for visually getting an idea of the profile of the surface. You can see it in different colors, and you can see it as in original color. You can turn it, you can move it. In this case with the touchscreen, it's very convenient. Then you have the point height measurement. You simply click on the one area you're interested in, and he will automatically generate the height of this point. And you will have the profiling, which I showed you before, where you can do different measurements, angles, radius, diameters, heights, etc. And also volume and area. I will show you this on the microscope later with some samples, so we'll get a rough idea of this. 3D image profiling. The roughness, as I said before, it's certified, so you can use it for every application you have. You can also give it to your, you can publish those results. Thank you. You can publish those results. Those are officially correct. Good. Easy 2D and 3D tiling. You saw it in the video. The colleague made it with a coin. It's like panorama picture, and this is also what is made with the painting I showed you before. You can do very, very large images in very high quality. So you make an image of a whole coin, for example, with high quality, with high magnification, let's say 200 or 500 magnification, and then you have a large picture where you can zoom in and see a lot of detail. And also do 2D measurements, and there's also 3D tiling, so you can also do 3D measurements and 3D profiling. Even whole 3D models you can produce like this. Like for image stitching. Now a few pictures, just to get a few ideas what applications you can use. This is a painting. Bondings, insects, biology. Watchmakers, like here also watch. This is for forensics. This is a light in the car. You can see this crack here. This proves that the light was not working before the crash. Also, insects again, very interesting. Material sciences, metal structures. Yeah, a few 3D profiles of those. Good. So that's for the presentation. Now we'll give you a quick overview of our customers who is using the Hirox microscope. So we have the most customers in this category, electronics and semiconductors. You will probably know all of those companies. Yeah. The second is automotive. This is a very high growing area for our Hirox microscopy. A lot of new interests are coming. aviation and aerospace. NASA, for example, is using not just one of our microscopes. Cosmetics. L'Oreal is using our microscope to measure hair. So they take hair and do measurements, roughness measurements, and then they use the L'Oreal shampoo. And after that, they do measurements, and if the roughness is better, they know the shampoo is good. So this is how they prove they have good shampoo. Gillette, for example, is using it for the razors, for the shavers. They measure the angle of the cutting edge of the hair. So this is also they can say is it good or is it bad. Material sciences, watchmaker industry. Basically, all of the known watchmakers like Rolex, Tag Heuer, Blue, and all the other bigger brands you know, they all use the Hirox system. Because it's the only system which has this kind of rotary head they need to get under the structures of a watch to get the best idea. Does it work? How it should work. Yeah. They need to have very high quality management because they sell really expensive watches. Everything needs to be perfect. Chemical also. Medical devices. And military, pharmaceutical, forensics, criminalistics, also a big field, a large field in this microscopy, Hirox. Agriculture, food. Heineken, for example, is not measuring something with their beer or whatever. They are just doing measurements for the bottles, for the quality of their bottles. Also a big thing they use. And yeah, a lot of universities. And yeah, last year we started to talk to a few libraries, and we already got a few. So libraries is also a very interesting category for it's the same as art. So they have very old books with paintings, and this is what they do. They need to restore it. They need to do measurements and also digitalization. Everything done with the microscope. And museums. So basically a lot of the most important museums in Europe use it. Vintage. And yeah, different institutes, the Fraunhofer Institute in Germany, the Max Planck, Paul Scherrer, you probably know all of them. And yeah, that's it. Thank you very much. So, if you have any questions, please. No questions?
You only get one question before When did you produce this one? First time, who can use this one? Which company?
This one?
Yes.
The first sold item, what do you mean?
Who got this devices?
This new model will be.
This new one, who got it
This was
now?
made 3 months ago. This
Yeah, we have
Just for us. This is manufactured just for us.
we actually sold already a few of them.
There?
Yeah, we sold it to the Bavarian State Library. We sold it to BIC, you know, BIC, the lighters. They do lighters and shavers. We sold one to Philips. We sold one to, it's called Brose, the German company, automotive. We sold to Bosch in Austria. This is actually my area, I don't know about the others.
So which is not here.
Yeah.
So the next is EOS.
So the next, hopefully, iOS, yeah.
I have 2 questions.
Yeah.
What about the lamp that you're using for illuminating the sample?
Yes.
So, what's the lifetime of this lamp?
It's LED lighting. This, yeah. And the lifetime is counted on Japanese working hours. It's 30 years.
30.
But counted on Japanese working hours, which is like 6 days a week. I don't know, like 50 hours a week. So 30,000 hours.
70 hours for the
Do you
Something
know
like
the
So it
wavelength
doesn't know.
of this?
No, but I can check. Можно
Okay.
написать, да. I can check, yeah.
Okay, I read that 3D reconstruction. So this is a separate software or something included?
3D reconstruction, yeah. So 3D profiling, 3D imaging is included,
Yes.
and there is 3D reconstruction, which is which we're still working on. Actually, it's finished. Now it's going to be integrated in the system. So 3D reconstruction works like this. You use the rotary head, like in this case. You take a sample, the rotary head turns around one time, makes the video, and then you process those images and make a 3D reconstruction with with a 3D model. So you'll get a 3D model like this. Reverse engineering, for example, a very nice use for this, and you can do different measurements on this step or compare. Yeah. So this is something that will be probably integrated in the system in the next weeks, I hope.
Very good information is that once you purchase the equipment with software, you get all updates free of charge.
Yes. We do updates.
For a lifetime.
Yeah, we do updates every 5 to 6 to 7 months, and all updates are free. I simply send you the update, you can install it, and there are a lot of new features. For example, this, I don't know if you remember in the presentation, I showed you this height measurement, point height, where you just click on one point and you know the height. This is a feature which was added half year ago, and also for free. So software updates are always for free, bug fixes, etc. are always for free.
We can show some low samples first. And then they
Yeah, sure, I can show that.
Wszystko po prostu. Nie, no,